There it goes. Let's start. And this is our first session of Python. So we'll be meeting every day, and I'll just be giving you. I'll be giving you a lot of examples, hands-on examples. The end of the day, we'll be doing some project also on the basic core Python and machine learning, artificial intelligence, and all the other things. So the stuff we've got a lot of concepts to deal, and our road is way ahead. It's a very long journey for us, rather. But anyhow, still we have started. We are starting our Python from today, and I'll just guide you in such a way that your systems are pre-loaded with Python software. So I'll just even help you on that particular thing also as to that. But first, to start with the basic introduction of what Python is. Python is a general purpose high level language. So general purpose means normally when a programming language is invented, it'll be there for a specific purpose. So I just here mean specific purpose mean, for example, if Java is invented. So Java is invented for an exclusive, initially when it was invented for an exclusive reason that it fulfills the needs of web application development. So similarly C++ and even similarly Visual Basic. There are many languages of that kind that are used exclusively for some specific purposes. But Python is not of that particular kind. So it's a general purpose language. We can design and develop a web application. Python is used for machine learning and artificial intelligence. And Python is used for graphical user interface programming. That is what we call GUI. So it serves many purposes, not just one single purpose that we have got. Just many purposes that we have got. So many purposes means what? Number one, rich user interface. The user interface is nothing but the UI. Like say, normally when we interact with any of the applications of the tools that we're just using with, we make use of several widgets. See, we make use of buttons, we make use of text fields, we make use of text areas, we make use of radio buttons, we make use of checkboxes. Lot of graphical user interface widgets we'll be using around. So that's what we call rich UI as user interfaces. Python uses all those particular things in order to rather just work with. So that's the first, very foremost usage of Python, number one. Number two, Python is a very strong web development. Normally, for any web application development, one of the best programming languages that we've got is Java. Java is said to be as one of the very powerful, very strongest programming languages that we have got. So why? Because Java was mainly intended for developing or intended for developing web-based applications and websites and all the other stuff. So that's one of the main purpose why we just go with Java. Similarly, .NET. So Python has caught the bus to compete with Java and .NET and other than just PHP. Perhaps all of you would have heard about it. There is another very fantastic programming called PHP. So it has that serves the purpose. So that's the reason it is rich in user interface, a very strong web development. So web development in the sense there is one programming language called Django, which is very popular and very powerful in Python. So we do that for our web development purposes. And third and fourth general purpose language serves a lot of things for Python. Python is very powerful and very strong due to that reason. One is rich in machine learning. These days around, machine learning is catching up a lot. Machine learning and deep learning, artificial intelligence, we call it. So there are a lot of smartphones, there are a lot of smart devices that we are using every day in our life. So all those smart devices that we are using are programmed using deep learning, using machine learning. We train our device in such a way that it can speak to us, it can recognize us, or rather, it can recognize our voice. So all those things can be done obviously like that. You'll see that when I just go into the deeper of Python sessions as to how it just learns and how to train Python in such a way that it learns all the activities that we need to perform. So that's another reason that we just use for. And then comes the other one called testing. So it is used to test applications. That is the Selenium. We do call it a Selenium rather, in fact. So testing plays a very important and major role in every software development. Like If it is Java or Python or any other thing like PHP or web test or anything, we just basically make use of Selenium. So in order to use Selenium can be used along with Java, it can be used with Python, so it can be used with many applications. That's the again another biggest advantage that we've got. Then we do have the other one, and that's what we call Python is used in data analysis and visualization. That's the thing that we just do it. It's used in data analysis and data visualization. So data analysis and visualization means these days it plays a major role. Like say we have got a concept called pandas. Pandas are nothing but panel data. That is what you call panda as. So mainly used for visualization, mainly used for mainly used for analysis. That's the thing that we do have it. So this is what we call basically one of the main feature that we got for Python. Then we do have the other one. That is, let us just go with the features of Python that we have got. The features of Python is number one, Python is platform independent language. It's basically an independent language. That is Python. Today we are going to see the architecture. I'm going to discuss about that particular thing as to what machine independent languages are. It's based on Aura. Aura is write once, run anywhere. I'll be discussing about that particular thing. Then number two, Python is very simple and very easy to author. This is one of the greatest advantages that we've got for Python. Any one of us with a minimal logical skills can write. There is no problem with the syntax that we're just using with. No hassles in using lengthy code. No hassles in writing a very big code in such a way that we fall in trouble and all. Very simple, because it's a scripting kind of a stuff, a scripting language kind of a stuff. You'll see the coding part of it, how simple it will be and how easy it will be in order to write a Python. So that's one advantage that you got. The third most important advantage that we've got is basically Python is open source. Open source means it is the general public license software that we just use it in fact. So Python is GPL. So general public license. That is what Python is all about. Then you got another one called portability. Portability means Python can be ported or transferred. There are few restrictions to some of the languages, which I've just seen. In order to make that language work on Windows, or in order to make that languages work on Mac OS, we have to have special APIs and special packages in order to make it work. But Python is not of that particular kind. So it can run anywhere easily. It can get installed. You can make it work in a very simpler way. That's what we call open source as. So it's GPL, which we call it as general public license. Next, unportable. So one of the main reasons why Python is very popularly used for both web development, for both artificial intelligence, and for all the things is it is secure. Python is secure, and secure applications can be developed using Python. So these features make Python feature rich. It's really it makes a terrific feature rich concepts that we've got. So that's the reason why we're just using it. Well, this is the thing that we just do it. Then coming to the history of Python, Python dates back to 1991. But when it was invented in 1991, why is it popular now? Why is it that most of the developers are behind Python now? As I've told you, the functionalities of the rich artificial intelligence, like machine learning, deep learning, are introduced in Python only after, in the recent past. That's one of the main reasons. Now, Python was invented by Guido van Rossum. So he's a Dutch scientist. He's invented this particular thing. Then the main version that we have got for Python, let us just see the versions. Versions in the sense, every the order of the day is that Python updates itself very frequently. So a lot of new features will be introduced for making Python more ease of use. Might be some language changes might take place. Might be some coding changes might take place. Might be some internal process might take place. So there are a lot of changes going around for Python every now and then. So it started its version from 0.9.0 in the month of Feb 1991. Then then the Python got upgraded to 1.0 like this. So in the year Jan 94, and then Python 2.0 to October, and Python 3.0 in the month of December 2008. But the latest version that we've got for Python that we're just using it is obviously 3.7.3. That is the latest version. Just would like to rather just open that to show you as to how the latest version works with. And so is it another big concept is what should I have in order to rather work with Python? The software requirements, the needs of software requirements in order to rather work with Python. Let me just figure it out. So, but first, in order to work with Python, you need a Python software, which can happen like this. Python.org is the site that we just use it. So, with the help of this particular thing, we can download the base Python software. Let me just show you through where we have the base Python software and how it just works. Yeah, you can see here. This is how we see it. And here comes Python 3.7.3. So it can, I mean, it's released for all the platforms. You're working on with Windows, fine. Or you're working with Mac, sounds good. And the other platforms also. But since I'm just using Windows, I have a copy of Windows version on it. So this is the base Python that we install. And it's very easy and very simple, pretty good in order to work with. Very simple. Installation also takes place in a very simpler way. Anyhow, I'll guide you several steps in the process of installation. Not much required, but a small skill is required in order to install. It's a small, a very small tip is needed in order to install Python. I'll just show you as to what we need to do it. Well, this is the first one. Then comes the other one. See, just by having base Python, is it fine for me to rather just work with? Yes, of course. The answer is yes, of course, because when we just have only Python, we have got a tool called idle. You just see here. There is a tool called idle. With the help of it's an REPL tool. I'll be soon today introducing you this particular tool in order to just write the code. So I just need to open that particular REPL tool in order to write the code basically for Python. That's what we'll just be doing it. Yeah, this is the tool that we got. But I just would like to have a very user-friendly tool that interacts with me, user-friendly tool that where I can just write coding in a simpler way and in an easier way. For that, we have a tool called PyCharm. So there is another one called PyCharm. So let me just go with that particular thing. I'll just go with JetBrains. So there is JetBrains has invented this particular thing, and we just do call that particular thing as, in fact, this one. Yeah, you can just see this. JetBrains PyCharm. This is how we just do use it. So in this, we have a tool, and that's what we call, yeah, we have a tool called PyCharm over here. Yeah, Python and Django. There's the thing. So there's a tool that I just need to rather just go with. Yeah, here it is. This is PyCharm. We just have to download this particular thing. But the advantage of this particular thing is it's not just downloading it. You have to rather identify that there are a couple of versions called professional and community. Community is a freeware which we can just download it. No hassles of licensing and all. So you might ask me, you said that Python is open source, and how come it has changed it to purchase version? Python is obviously an open source. This is 100% open source. No need of any licensing. We don't have to buy it or anything for that matter. But the tool that we use comes in two versions. One is professional, the other one is community. Community is absolutely a freeware. So no hassles in getting community. But professional version, it works as free trial. In order to get it, we have to buy it. So the advantages of working with professional version is that it just supports a very strong, rich web development. Of course, I do have a key. I'll share it with you. No worries on that particular reason. So because I do use professional edition, so that's the reason why. Or else otherwise, the basic core programming, wherever you write, it's the same, whether it is community or professional. So this is the first one that we have got. Number two, the second interesting concepts that we have got with the software that we have got with Python is that we have a software by name Anaconda. So it's a bundle thing that we've got it. I'll just show you basically. Let me just go with that. We have got a software called Anaconda. Anaconda binary distribution or Anaconda download. Let me just say. I'll give you the speciality of this. Anaconda download. Yeah, download for Windows 10. See, the advantage of Anaconda is Anaconda, it's a Python distribution that comes with a lot of functionalities. You don't have to install a lot of things because in PyCharm we have to do it. Yeah, you can just see all these modules comes by default when you work with Anaconda. You got Jupyter, you got Spider. Spider is an editor that you use for Anaconda, and moreover, Anaconda comes with Python and R. It's a very famous, popular data science platform for both Python and R distribution. That's the reason why we just use Anaconda. So I'll just teach you even in Anaconda also. I'll just teach you in Anaconda also very shortly. But first, let's get acquainted with this PyCharm. Then we'll move on to Anaconda distribution. Because if you download Anaconda, you don't have to even install Python. Python comes by default within Anaconda distribution. It comes with Python. It comes with a tool called Spider. It comes with another tool called Jupyter. That's a web-based tool. And it comes with a lot of modules like NumPy, SciPy, Numba, Pandas. We are going to discuss all those things in our coming up discussions, right? Coming up sessions. So this is one of the very popular, very famous Python distribution. Python and R works for both the things. So here is Anaconda that I've just got. So this is Anaconda for you. I just wanted to show you as to how it just works. Yeah, this is Spider. Spider is where it is nothing but the graphical user, or rather the tool that we use for Python. Well, these are the software requirements that we need in order to rather just work with Python. Coming back to our thing, this is how it just looks like. Well, now we have software with us. Next one. Before we code, we have to ultimately know the architecture of Python as to how it just works and like say why it is so popular and what is this machine dependent as, because I've given you the features with one good reason that it is basically a machine dependent language, machine independent language. So I just need to give you, yeah, you can just see there. Platform is Python is platform independent language. Now, what do we mean by that? Let me just give you a very clear idea on what machine independent languages are. But before we start our training on machine independent languages, let's just learn what machine dependent languages are. In order to know what machine dependent languages, I'll give you one of the best examples that we've got called Dev C++, because I'll be opening up this editor. It's an editor for writing C and C++ coding. So let me just open that, and I'll just take up a small pictorial representation as to teach you as to what machine dependent languages are. Let me just open that particular thing. Here comes, yeah, machine dependent. Just look into this diagram, all the three of you. So this diagrammatic, yeah, it's not yet loaded. So this diagrammatic representation that it'll load will give us a very clear idea about what machine dependent languages are. So what are machine dependent languages or platform dependent? So first, let me give you what is platform. Platform is a combination of both hardware and software combined. It's a combination of both hardware and software. That's what we call basically platform as, in fact. So that means the operating system that I'm using, the machine that I'm using. So all these comes under the platform that we're just using it. So ultimately, when it comes to machine dependent languages, one of the best examples that we've got is C, C++. All these languages are machine dependent. Now, for suppose, let me take up a small C source code. We don't need to, you don't need to understand or analyze what I've just written here. This is the source code that we have taken. Yeah, just look at this. Yeah, this is the source code that I've just taken up the C source code. Now, what is that? I'll just do it. So after writing the C source code, I'll be compiling it with the help of a compiler. Why? Why do we need a compiler? We need a compiler because the source code that we have written here cannot be understood by the machine. Our machine cannot understand. A Windows machine cannot understand the source code that we have written. That is the problem that we've got. So our machine cannot understand the code that we just do right. So in order to make my machine understand our code, we need to translate it to binary code. That's what we need to. We have to do it. We have to translate it to binary code. Binary code in the sense the machine code. So for that reason, I have to compile this particular program. Here it is. I'll just be using a compiler. Yeah, here it is. You have a compile and run. So then what does this compiler do? This compiler converts the source code to machine code. That is what it will do. So now when I just compile it, you can see that it just converts the source code to machine code and then produces the executable file for me to display the output. There's some output. Let's not bother about the output, what it has just displayed it. So this is the output that we have got. Now the problem is, not the problem, suppose this sounds good for us when we are just working with Windows. You can see here that when I just write the code and I just compile it with the help of a compiler, and this compiler will create a couple of files, one called the object code. Object code is nothing but the machine code that can be understood by our machine that we're just using. Takes an extension of .obj, and similarly it just takes up another file called exe, or the executable code that it just works with. So just we have got a couple of files, one called object and executable. Executable produces the output. Now the problem is, now suppose you change your platform in the sense, suppose tomorrow I'll just get upgraded my PC with Linux, or might be with Mac OS. Then if I just want to execute the same C source code, that in order to make this C source code run on Linux or Mac OS, then I have to again compile it. So I have to use another compiler again to compile this in order to convert this to object file and executable file. See, this is the biggest thread that we have got. So that means every time we change our platform, it becomes obvious for us to rather recompile it. One of the best examples I can give you is that now when I'm in Punjab, so I have to ultimately learn Punjabi. Of course, though Hindi and English are the official languages that everyone speaks, but the nativity of Punjab is that I just need to learn Punjabi, or else otherwise I cannot survive. The same is the case with Tamil Nadu. The same is the case with Kerala. So a lot of places. That means I have to get acquainted with those languages. I have to compile myself in such a way that I have to get, in order to get recognized in those particular states, I have to speak their language. So that's what we call machine dependent languages. So that means every time we change a platform, we have to recompile it. And unfortunately, machine dependent languages are not viable or not suitable for web application development or for artificial development, artificial programming. So Python has smelled this way back in 90s itself. So that's the reason they've made it machine independent. See how beauty it was. So of course, they would have not introduced artificial AI and all the other features. Might be in late 90s. But when Python was introduced, it was quite comfortably. It has introduced a feature called machine independent. Now let's just focus on what machine independent code has. So one of the very popular examples that we've got for machine independent languages are Java, .NET, Python, and PHP. So all these languages which I've just taught you are web-based languages for web application development. We can design and develop websites quite comfortably. So that's one of the greatest advantages that you got with machine independent. So let's just go ahead with what machine independent languages are, how Python works, and how it just performs the task. We'll just figure it out. I guess you have understood, Balram, right? Till now? Any questions?
Hey, quick question.
Yeah.
So this compiler comes with the Windows will have its own compiler and Linux will have its own compiler.
Yes.
Okay.
Based
on that, the system will compile the
Yes,
code.
exactly. Windows
So
will have
it's
its
not the
own.
same compiler which can be used for Windows and Linux. It's
Excellent.
separate.
Exactly. Windows will have its own compiler and depend. See, that's the reason I've just shown you here. This is the excuse me. This is the tool that I'm just using in Windows, and it has got its own compiler. Now, if I go to Linux, it will not be there for you in execute menu. It will be there somewhere, or it has to compile according to its requirement. Okay, Palak.
Yes, thank
Yeah,
you.
that's fine. And Chandu, have you got it? Stuart?
Yeah, I got it.
Yes, excellent. Seems Balram, when isn't, yeah, Balram is active now. Yeah, I guess you
Yeah,
also understood it, right?
yeah, I'm good then. Yeah.
Yeah, that's fine. So now let's move on to the machine independent, because I just wanted to have a checkpoint, because before we move on to machine independent, we have to be very thorough with what machine dependent languages are. And here comes the notes for it, because all the machine dependent languages are traditional languages, like say C, COBOL, Pascal, C++. All these are machine dependent languages. Number one. Number two, the source, we have to understand what a source code is, obviously, over here. The program that we write is said to be a source code. So the code that we use is called a source code. It means a machine cannot understand the source code. It can understand only machine code. And this machine code will be in the form of binary instructions, which is in the form of zeros and ones. That's what we call basically source code as. So now, what's translators basically first? Translators mean they convert our source code to machine code. That is the binary code that we have, obviously, like that. So translators are classified for us into two types. Number one, compiler, and number two, interpreter. These are the two types of translators that we have. First one is compiler. Second one that we've got is interpreter. Compiler means it's a translator that converts the entire source code to machine code at once. You need to know both the beauty of translator is that both the things perform the same task, converting our source code to machine code. But you need to get the basic difference between compiler and interpreter. There are two different types of translators. One is compiler, the second one is interpreter. Compiler is a translator that converts the entire source code at one go and then converts it to machine code. So that's what compiler does. Now, when it comes to interpreter also translates. That is also it also converts the source code to machine code, but it just does it line by line. That is the big difference between compiler and followed by the interpreter that we have. So you can just see how nice it is. This is the thing that we've got. Well, C, C++ are compiler based languages. C, C++ are absolutely compiler based machine dependent languages. I have just shown you the pictorial representation of it very decently. But now, yeah, this is the thing. In machine dependent languages, every time we change our platform I mean hardware and software requirements. Every time we change our platform, we have to compile the source code. That is the problem that we've got over here. Then comes machine independent languages. This is again another very good one. These are otherwise called as platform independent languages. We call it with that particular name. Platform independent in the sense here we write the code once, compile the code once, and execute the code many a times. We just do write once. We compile the code once and execute it every time and everywhere. And this is what we call WORA. WORA means write once, run anywhere, execute anywhere. That's what we just do call it, in fact, basically. I'll tell you the magic of this as to how it just works. Let's assume that we have written a Python program with some name called example.py. Let me see if I've just got a diagrammatic representation. I just do have a diagrammatic representation, I suppose, for that matter. Just check it out for it and yeah. Just look at this diagrammatic representation that I've got. The machine independent code. Yes. So if you just look at this diagrammatic representation, let's assume that we write a Python program, a Python source code with an example.py. So here it is, example.py. So you make use of the syntax of Python and write the entire source code. Now what is that we do it? We compile it with the help of a compiler. We use a Python compiler in order to compile it. So as soon, I mean, after we compile it with the help of a Python compiler, what does Python do? Python never creates an object code, or Python never creates an executable code, unlike our C or C++. Then what does it do? Python creates a bytecode. That is what it just does. What is bytecode? Bytecode is a machine independent code. So you can just see here, this bytecode will be with an extension of .pyc, that is Python class. Basically, it just creates a class file. Python class is the name that we just do get it. So observe this very carefully, and if any queries, please ask me. No issues on that particular aspect. So when you just look into this, yeah, here it is. Every Python program needs to be compiled with Python compiler. The Python compiler converts the Python program into another code called bytecode. And remember, Python is purely and strictly an interpreted language. It's an interpreter. Then what does this compiler, interpreter, all these things mean? Now let me tell you that when the Python code is first returned, it gets loaded inside like this, this one. Yeah, this one. This architecture will give you another clear picture. It will be loaded in, it'll perform the interpretation task. Just performs the interpretation task in the sense the entire structure of Python programming is wound around the interpretation. Just observe this diagrammatic representation very clearly. If you just see this, you choose an editor for Python, write the source code and interpret it. While interpreting it, internally it again compiles. That's what I'm telling you here. So that means we have nothing to do with compilation. We have nothing to do with bytecode. We have nothing to do with virtual machine. It's all the internal process that takes place. But we have to have a very thorough knowledge of it as a point of view, because they'll be asking what machine independent languages are and how does it differ from machine dependent. So for that reason, I'm just telling you all these particular things. We need to have a very thorough knowledge of what Python does. So that means we make use of an interpreter in order to interpret this particular code. Once we interpret it, a compiler comes in a picture. A compiler compiles internally, and within the interpreter, you'll be having a compiler. It compiles with the help of a compiler. Then it produces a bytecode. And this bytecode will be in the form of .pyc, we call it. PYC in the sense Python class. Just takes an extension of .pyc, like I've just shown you in the diagrammatic representation that I've just mentioned it for you over here. This is the thing that we've got called PYC. Now, what happens to this particular PYC? So this PYC cannot run on its own. That is the speciality of PYC. See, in C, it's not like that. In C, you have an executable file that runs on its own. Even if you don't have C software, it runs because all the executable files run independently in operating systems that we're working with. But whereas in the case of Python, it is not so like this. Bytecode cannot run on its own. That's the problem that we've got with that. So then how does bytecode go with? Bytecode will be loaded into another machine called PVM. Now this is the big one. This is the big one. PVM, I hear mean Python virtual machine. That is PVM. PVM, we here mean that it's called as Python virtual machine. Virtual machine, we call it. So what does this particular thing mean? Python virtual machine means it is an imaginary software. So it is not a hardware device, nor you do not need to have a separate component in order to rather install it in your machine. No, it's just a software, an imaginary software represented as hardware. That is the specialty. You know, why should I have a software that is represented as a software? Again, another question. So what PVM does is it loads, okay? It loads the bytecodes into it. You can see in every diagrammatic representation that I show you here, your PVM loads the bytecodes. Bytecodes are getting loaded into Python virtual machine. And it loads even the library modules. There are a lot of libraries, built-in libraries available. It even loads those libraries into virtual machine. So your bytecodes will be loaded, libraries would be loaded, and then now your virtual machine sees from which operating system that you have interpreted it. Now look, I've just interpreted it from Windows. Cool. Now let me convert this to Windows understandable. So your Virtual machine converts this bytecode to Windows understandable and then runs the code or produces the output. Now, what happens if I'm just using a Linux platform? In Linux platform, I don't have to rather do all these hassles, nor I need to have this code. If I just have simply .pyc file, I'll just copy it in Linux, and then let us assume that we have got a Python interpreter. Then when we interpret it from Linux, again internally it compiles, and this bytecode gets loaded in virtual machine, and it's a virtual machine that identifies that you're running it from Linux operating system, and then produces an executable, runs the code. So is the case with Mac OS also. So you don't have to run it, compile it, and all. Just copy your code or copy your PYC file. That will take care of it, and the same PYC file will be loaded in virtual machine. See, the other you're doing this process only once. For the rest of all the other devices, only this process will be. It starts only from this particular process. Bytecode getting loaded into virtual machine recognizing from which operating system you're working with, and then it just produces the output. That is what we call machine independent code as. This is how interpreter works. I guess all the three of you have understood. This is a very important topic. Yes, Balram Garu, you understood this particular thing, and Palak and Chandu.
Yes.
Yeah. Any questions?
No.
No. Okay. Chandu Garu, you got any questions?
No questions for now.
Right. So this is what we do. Use it like, say, the compiler, the interpreter, and then internal. That means there was one very peculiar question asked in the recent interview sessions while I was interacting with few guys. You know what they've asked me, what they've told me was, an interviewer has asked them, it seems, there's a Python interpreted or compiled language. There's no doubt about it that we have to say that it's an interpreted languages. The very simple clue is that almost all the scripting languages that we uses an interpreter. Python uses an interpreter. PHP uses an interpreter. Almost many scripting languages are there that uses interpreter quite confidently. Then what does this compiler do for you? That's what they've asked. So you say that it's an interpreted language, and then you say that it uses a compiler. Why do you need all these particular things? That's what they've asked, it seems. Now, see, internally, it's an internal process that you need a compiler. It has a compiler, because compilers are faster than interpreters. So that's the reason we interpret it and it compiles it. In one line, we interpret a Python source, and it, in the sense, the Python interpreter interprets it and compiles it internally to bytecode. That is the PYC file. This is what we have to rather just say. This is how the Python interpreter actually works, in fact, in a very simpler way. So that's one of the main reason why Python is in tandem, or it is picking up pace with Java. It is picking up. It's becoming a very tough competitor to Microsoft products for web development, because of this particular machine independent functionality that Python have. So this is the basic introduction of the architecture that we have got. We'll move into the coding part of it also. That's what I've just written here. You can just see bytecode represents a fixed set of instructions that represents all operations like arithmetic operations, comparison operations, which run on any operating system and any hardware. It means the bytecode instructions are system independent or platform independent. It's absolutely platform independent. Now, Python uses an interpreter which understands the bytecode and converts it to machine code. And this machine code, or the bytecode, gets loaded in PVM. That's the reason I've just given you the steps over here. You just see the steps. Just check on to this particular steps. After writing the Python source code, we compile it, or rather we interpret it. Let me just put it like this. After writing the Python source and interpret it, okay, so it creates a bytecode. So bytecode, after creating a bytecode with an extension of .pyc. Now these PYC files are loaded in PVM. Okay, so this PVM is an imaginary machine, Python virtual machine, you call it. The name itself goes like this. It's a virtual machine, we call it. Python virtual machine is a software. When PYC files are loaded in the PVM, And when we try to interpret it, PVM recognizes the operating system from where we are interpreting it, and then generates a machine understandable code and finally displays the output. That's how the Python goes, and that's the reason why we call it as Python as Vora. Vora is write once, run many times, and this is the very clear diagrammatic representation that I've given you clearly as to depict as to how Python interpreter works. Very simple reason. Now I told you that this is the, in fact, one of the basic architectures that we just use for Python in order to make it work, in order to make it run. Now, what's up? The next one. The next one is I can just take up the first Python source code in order to make it work. In order to write our Python's code, I've already told you that our machine should and must be loaded with PyCharm. I do have PyCharm just here. And all these are the projects that I have created. So now, since we are into the first session, let us create a new project. I just can take up a new project. Yeah, you can see that this is the difference between the professional edition and community edition, which I was just showing you earlier. When you look into this community edition, you don't get all these. We don't get all these things. Let me show you all these things in the sense. Yeah, all these things. You don't get Django. You don't get Flask. You don't get Pyramid. You don't get scientific SciPy. You don't. I mean, even in PyCharm, you can write an Angular code, AngularJS, Bootstrap, HTML5 boilerplates, and React.js. So all these are scripting languages which you can just write at one go. So you can even integrate your Angular applications with Python. We can even integrate our React applications into our Python. So all these things we can just do it at one simple go. So this is not possible in community edition. In professional edition, it sounds good. We can just do it. Now, just have to create basically a project name. And this project will be loading in users and followed by my folder with PyCharm projects. The moment we install it, it just looks like this. So I'll do one thing. I'll just share the key for professional edition. In the meantime, all the three of you, please download this Python copy of it. Don't install it, and PyCharm also. What I'll do is I'll install it tomorrow into one of your PCs. It might be Chandu's or Balram's or Palak. So I'll just be installing it in one of your PCs. Just see as to how I install it, and the others can follow the same. That's how we can just do it. In the meantime, you just have to rather just download the copy of it. That's what I just want, basically. Now, after this particular thing, I'll just move ahead with the thing called, I'll just write it like this. Something called sample project. Sample project like this. Yeah. So there's a thing, or it's already there, which I've just said it. Or let me just say something called intro. This is what I've just given, intro. So we're going to take up the first examples and all the other things as intro. This is a project that I'm just going to create. I just say create. Yeah, here it is. You can see that the project is created. Yeah, I'll give you the tasks even from tomorrow, right? Starting from tomorrow, because we have a lot to discuss, and I'll be writing up the first, and I'll give you a lot of examples in our tomorrow's class, and then I'll even give you some tasks to work. But first, our prior step is to install Python in your PCs. We'll do that. So it's just creating a virtual environment. You can see here, this is PVM. It's just creating a virtual environment, and it creates a project for us by creating a virtual environment. After creating a virtual environment, then a project gets created and we can write our source code. Yeah, here it is. This is the project that we've just created it. Yeah, this is what you call the Project Explorer window. Just contains just an intro, the project name that we've just created with, and followed by the external libraries. Just using basically Python 3.7 version. So that means your Python has to be mapped. I'll just give you one simple example. Yesterday, there was a guy who came to me asking me that Python is not running in his machine. in spite of installing PyCharm. So I could able to easily figure it out because immediately I've guessed. Look, you don't have Python in your machine. I've just said. He said, no, I just do have Python and all. No, I've told no. First thing that you need to install is you have to install Python. I've already done it in my. Let me just show you. It's here that I've just done it. Yeah, it's here that I've just done it. You can see here. Yeah, it is PostgreSQL and Python. Yeah, here it is. This is Python. I have installed Python. So that's the reason I'm able to work with it. Likewise, henceforth, his machine wasn't equipped with Python. So that's the reason even if you install PyCharm, you cannot see the external library here. So the first prerogative task is that you have to install Python in your machine. So then only it just works. Scratches and consoles or additional APIs that we'll be looking up with. Well, this is the code window that we've got. So let me just add the code, right click on it, and I'll surely introduce you Anaconda, Jupyter also very shortly. Please wait. So I'll just take up new and then Python file. There are so many options over here. We've got Python file, we've got Jupyter, we've got HTML page, we've got style sheets, so JavaScript, TypeScript, a lot of things are there. But I just want Python file. Let me select that. Here in this Python file, let us name it as example1 and just click OK. So the moment I just click OK, yeah, you can just see there, it has created basically a file for me like this. Wow. Now I'm ready to write the code in a very simple way. And you can see that it takes an extension of .py. It's not the it's not any other extension. You got py. The moment I just run this code, it creates pyc also. I'm ready to show you where pyc will be also basically located. And we can just even do that. So, I'll give you that very peculiar situation. There was in my recent past, there was a situation where a student came to me asking me that her project got completely deleted. She has done a project in Python and all the source code got deleted. And her mentor was forcing her to show the source code. Now she don't have the source code. So, and unfortunately, she has not copied it anywhere elsewhere also. That's the biggest problem that she had. And she came to me. And I told, yes, look, do you have PYC files? If you have PYC files, with the help of re-engineering, you can get it back. Or reverse engineering, you can get it back. You can get back all your source files with save. So fortunately, she had all the PYC files in her machine. And I could able to bring all those particular PYC, convert those PYC files into .py file and give her the source code. I'll even show you that process also very shortly. But as of now, it just basically creates .py file. Now, Python always starts with the commenting. Comments play a very important role for any programming, whether it is C or C++ or Java or anything for that matter. Comments play a major role. So how do we represent a comment? So in order to represent a comment, we either use hash. Hash is used. What does first comment speak about? Comment is nothing but the documentation. Like say, suppose I've just written a code and I've shared it with you, all the three of you. Then you have to understand what I've tried, right? So you have to first understand what the code is doing for us. So what's the scope of the project? Who has created it? At what time it is modified? So all these things counts a lot when you're working on a team, in a team. So obviously, you just have to see in such a way that comments are represented with hash. This is what we do it in fact. We just do represent it with a hash. I'll just say my first program. This is what we call comment as. This is how we just do represent comment as. My first program or my first source code. Not program or my first source code. This is how we just do it. Source code. This is how we do it in fact. So now, having written this, in other languages, I have to take lot of hassles. Just a second, both of you, or all the three of you, please wait. Yeah, I've just written it like this. basically as hash, my first source code. But now there are two ways of representing comments. Now the first one that we've got is basically, by giving a hash. The second one is what we call it as document commenting, in the sense that it's a multi-line commenting. You just give a triple quote like this. This is how I just give, and I'll just simply say my first program. This is how I just need to write it. This is called a multi-line commenting, created by something like this, Chandra, dated, say like this. This is how I've just done, 12/6/2019. So this is how I've just written. Yes, see. Well, this is called document commenting. When your comment spans across multiple lines, then this is the best comment that I just suggest. Give a triple quote 3 times, triple quote, triple double quote, and then it automatically terminates or ends with the triple double quote. But if we associate this with a variable, anyway, I'm going to discuss this tomorrow as to what variables are, how it just works and all. If we associate this with a variable, then it becomes basically a string. So that is the reason why you call this as doc string. So anyhow, I'm going to be more detailed into that in my tomorrow's class, because I'll be introducing you with data types, variables, constants, all those things. But as of now, this is basically the comment, the triple quote, okay, and then followed by the hash symbol. We can either as well use both the things. Now, how to write the first code? If it is C programming, I have to create lot of background is needed in order to write the basic code. And Java, oh my God, really, you need to know a lot of basics on it. You need to import packages. You need to include the class file. You need to include the main function. A lot of things have to be done. Thanks to Python. Python doesn't do all those sorts of things. It's simply, there is one simple function called print. You can start directly by writing the output statements. No main, no code blocks, no semicolons, nothing. That's what I was telling you. It's just like a scripting part of the language that we just do right in an easier way. Just simply say print, welcome to Python. That's it. Finish. We have written the first line. And even you can just do work with the second line also. Python world of artificial intelligence, AI. That's all. So there's the thing that we've done. Now, in order to run this code in an easier way, I just select this, right click on it, and run. There's a thing that I'll just do. I'll just have done it. And here it just comes. See, we are interpreting it. Internally, it has compiled it. And as soon as it gets compiled, it just creates a PYC file. And that PYC file gets loaded into PVM. And PVM recognizes from which operating system, from which platform that we're working with, and then produces the executable. All the process that I've told you earlier was an internal process. It's not an external process as to how it just works up with all. And you've just seen the output. Yes, you've understood this, Palak, right?
Yes.
Yes.
So, but where is the PYC file?
Yeah, I'll show you. I'll get back to that. I'll get back to that particular thing, because more about the architecture, I'll just be focusing it in my tomorrow's session, and I'll just show you where PYC is and how to interpret PYC and how to work with it. We'll analyze this project where it is being stored, this particular project. Then I can just show you where PYC is and all. A good question, Palak. And Balram, I just guess you've understood this particular thing, right? Balram, good? Yeah, good. Any questions?
No, I think I'm good.
Oh, no problem. Just think of it, and you can ask me if you've got any questions to ask. Well, Chandu, for you, Chandu.
No question.
No question. I guess you've understood as to how to write, right? I just
Mhm.
so all the three of you, please download the copy of PyCharm and Python. I'll share you the key now itself, and I'll save this particular file, and I'll put it for you in for your mail, and I'll install it in one of your machines tomorrow. Might be Chandu or might be Palak or Balram, whichever is convenient. I'll just be doing it. But ensure that any one of your PC has got Windows rather, because I'm more comfortable with Windows and Linux than Mac OS. might be anything. Even macOS also can be done. I don't mean to say that, but I'm comfortable with those couple of operating systems that we're just working with. So that's the reason. Well, this is the first code that I've just written, but there are so many things to come around. So we have got a lot of formatting functions. We have got a lot of format to do with print functions, print statements. We have got a lot of things like say PYC and how to interpret PYC and to see to check as to how it just works. All these things I'll be coming up in my tomorrow session. It was very nice that I've just taken up the entire. I've introduced you the coding part of it today, and down the line in my tomorrow session, I'll be coming up with lot of hands-on code rather than the theoretical part of it, because anyhow we have to even look into the data types and variables. But still further, just wanted to rather give you a lot of exercises, and I'll give you some good hands-on exercises also for the next class when we just do meet. And well, let me just stop this. Yeah, every